Hello, everyone. Hello. We're going to keep working on the factoring foldable today, so super fun. Okay, we've gone down pretty far. We only have 3 left. And so today we're going to look at perfect squares. Okay, so perfect squares, there's actually 2 different methods for perfect squares, and we're going to look at both. One of them is just a shortcut. So if you don't realize that something is a perfect square in that situation, it's okay. And I'll explain what to do. But the other one is how do we factor something that's a perfect square if it only has 2 terms? So that's what we're going to start with right here is the difference of squares. So if I have a perfect square, let's see, there we go. Okay, if I have a perfect square, let's say here, if my first term is a perfect square, and if my last term is a perfect square, and there's a minus in between, all I have to do is take the square root of each term and put them in parentheses following this pattern. So for example, if I look at the example x squared minus 81, x squared is a perfect square because the exponent is even, okay? 81 is a perfect square because it's 9 squared. So what I'm going to do is I'm going to take the square root of the first term, to find my a. So square root of x squared is x. And I'm going to take the square root of my second term to find b. The square root of 81 is 9. The other thing that has to be true is this has to be a minus. If this was a plus, you would not be able to factor this, okay? It has to be a minus, and that's so important right here. Okay, this has to be minus. So it has to be subtraction. There we go. Okay, once I have the square roots, I'm just going to follow this pattern. So I'm going to open a parenthesis, and my a in this problem is x, then minus, and then my b in this case is 9. Close it. Then I'm going to open another parenthesis. My a is x plus my b is 9. And the order doesn't matter if you do x plus 9 first and then x minus 9, totally okay as well. Okay. Hopefully that makes sense. You're just taking the square root of the first term and the square root of the second term. Let's do another one of those. 64x to the 6th minus 9. Okay, so a is going to be the square root of the first term. Square root of 64 is 8. Square root of x to the 6th, you just divide that exponent in half. So it's x to the 3rd. And then my b is the square root of the second term, which is 9. So now that I know what a and b is, I'm just going to write it in the pattern. So my a, which is 8x cubed, minus b, which is 3. And then my a, which is 8x cubed, plus my b, which is 3. And that's it. They're factored. Okay. So this is how we factor perfect squares if there's 2 terms and there's a minus between the 2 terms. And these have to be perfect squares, right? If I have like 12x to the 3rd or something, that's not a perfect square. So that wouldn't even count, right? So they have to be perfect squares. You have to be able to take the square root of them evenly. So that's the difference of squares. Now this one, the perfect square trinomial, this is just a shortcut. If you don't realize that your trinomial, 3 terms, right? Trinomial, 3 terms. If you don't realize that your trinomial is a perfect square trinomial, you can still use Xbox or the reverse box method to solve it. Okay, so you can still use Xbox to solve and you'll get the same answer. It's just a shortcut. So let's look at, so A and B, the first term and the last term, have to be perfect squares. This has to be addition. So that last term has to be positive on both of them. Okay. And then so then you can take the square root of those. And if you can multiply the two square roots together and multiply by 2, and that's your middle term, then it's a perfect square trinomial. And I know that that sounds very confusing. Promise you it's not as bad as it seems. So let's just look at an example, and then I think you'll be like, oh, okay, that's not so bad. So our first example is x squared plus 6x plus 9. So my first term is a perfect square, right, because it's x squared. My last term is a perfect square because it's 9 and it's positive. So this might be a perfect square trinomial. So my a is the square root of the first term, which is x. My b is the square root of the last term, which is 9. Or sorry, which is 9, which is 3. And then I have to ask myself, what's x times 3? Right? So x times 3 times 2. You always do a times 2 right here, the times 2. And that gives me 6x, and that's my middle term. So that's what I was looking for. Okay, so if x times 3 times 2 is 12x, and this is 6x, then it's not a perfect square, and you just have to use Xbox. But since it is a perfect square, and since the 6 is positive, I'm going to use this top one, and I'm going to follow the pattern where I take a, well in this case my a is x, plus b, well in this case my b is 3, close the parenthesis, square it, and it's factored. And now a lot of people ask, well, where'd that 6x go? And I'm going to show you, you don't have to write this down if you don't want, but I'm going to show you. X plus 3 squared is the same thing as x plus 3 times x plus 3. If I distribute this out, x times x is x squared. X times 3x is 3x. 3 times x is 3x. 3 times 3 is 9. So when I simplify it, I get x squared plus 6x plus 9, which is what I started with. So even though that 6x term like goes away, right, in our answer, it's still there if I were to multiply it back out. That's the most common question I get is what happened to the 6, right? Okay, let's do another example and then we'll be done. So our second example is y to the 4th minus 8y squared plus 16. So things to check for, is the first term a perfect square? Yes, right? Is the last term a positive perfect square? Yes, so this might be a perfect square, so let's test it. So a is the square root of the first term, which is y squared. B is the square root of the last term, which is 4. And if I do 2 times y squared times 4, I get 8y squared, which is my middle term. So we're good. So this is a perfect square. So I'm going to follow along in the pattern. However, because the 8 is negative, this time I'm using the bottom one. The only difference is that it's going to be a minus b instead of a plus b. So I open a parenthesis. A, in this case, is y squared. minus b, which is 4, close it, square it, and that's it. So again, if you don't realize that something is a perfect square, you can still use Xbox and you'll still get the same answer. So no worries there. It's just a nice little shortcut if you're able to recognize that something is a perfect square. Okay, so that's it on perfect squares. If you have any questions, please make sure that you reach out. I know that we've been going real fast through the factoring. But we want to make sure that we have this down because it's going to be really hard next semester to do most of the stuff that we're going to do without the ability to factor and the ability to factor quickly. So reach out if you need help. Let me know. Let me help you. Let's go through some of the worksheets together, whatever we got to do. We got to advocate for ourselves. But if you feel like you have it, you're good to go, and I'll see you guys later.